Hi learners, now we will understand about running a timer 0. It is 8051 we have studied in 4th unit. So in that we studied special function registers, timer function of 8051. Now we will just write a small simple program how to run a timer 0. There are two timers in 8051, so timer 0 and timer 1. So there are two registers, okay, in 8051. That is, one is timer mode register and timer control register. So in timer, if you want to make timer 0, that's what our objective is. Timer 0 has to be set, that is, it has to run. So in that we studied thoroughly in 8051 4th unit SFR special function register. So timer mode register is for two timers. This portion is for timer 0. So we have to concentrate only this portion. So in this we need to select any one mode. Okay, there are 4 modes in the timer 0, so we can choose any one mode. So let us assume I am just choosing first mode, that is second timer mode 1. Okay, so mode 1, in the sense this should be 1, first mode will be 0 0, mode 0. So here this will be 0, and here if it is 0 it is timer operation. So yes, we are running timer, so it will be 0. If I make this as 1, this will be counter operation. Say yes, this is gate. Okay, so gate, fine. So gate enables the timer output. So fine, this one is actually it is in the software manner. Fine. So here timer operation, then these two bits decides mode 1. Yes, so what is the, this is completely ignored because it is timer, it belongs to timer 1. So total, what is that, this 8-bit collectively it is number 1 hexadecimal. So that is why we are actually first choosing mode, this one, number 1 hexadecimal, right, this format. So first choosing mode, right, this is placed in timer mode, and we have a separate 16-bit register, that is counter, for timer 0 as well as timer 1, that is counter 0, count 1. There we have TL0, TH0. Similarly we have TL1, TH1. So this can be divided into two parts. So here we can just ignore this 0 because it is required when you type it in the trainer kit, not now. So this is only 2 digits, right? So FF, the maximum value I am just placing. So FF here and FF. Okay, so FF is placed to TH as well as FF is placed to TL0 of the timer 0. So set bit TR0, that is timer run bit. Okay, so timer run bit is there in the timer control register, not in timer mode, timer control register. So timer is started running. So what is meant by time? Say an output has to be produced. Say an example, one response is coming, like, okay, an amplitude. Next we are counting till that time duration we are not producing anything. Then I am just sending logic 0 as an output, and then next time counting, reloading the count and counting, and then producing logic 1. Then next time counting, and again I am producing 0. This is how, this is your x-axis, right? It's your x-axis. So here this is your time duration, right? On pulse, off pulse, yes or no? So in that case we can adjust the count value, through which we can just adjust the time. So timer adjustment can be done. It is not mandatory that always you have to give FF. So we can reduce the values also. Okay, specific time we can calculate by just considering the clock pulse of the microcontroller, right? So, and based on that number of instructions required, for that how many number of clock pulse, and that has to be multiplied by the number of the count value what we place. So through which we can identify the exact time duration what we want, what has to be generated. Okay, so as a timer, when it runs, so how it runs, say it is actually decrementing. from FFFF. This is totally 64k times approximately. So here 64k times, right? So once it timer started running, then once the 64k times is over, then it becomes 00, right? 00. Then after decrementing 00, the automatically that becomes FF, because decrementing means what? Subtraction. So subtraction, controller will just borrow one number and subtract. So 00 minus 1, that becomes FFFF, right? So it borrows one number, right? So here this state is overflow. This is indicated in TF0 of TCON register. So that is TF0. If overflow has occurred, which means the count is over. Counting is over. 00 to FF. This portion is over. So after checking this portion, then we have to do the next process. So here jump if not the bit is set, J and B. What bit? TF0 is not set. If not set means what? Still the counting is going on. Okay, then jump to the loop. Loop is where? Here itself. So it will be rotating here itself. So unnecessary. So this is what our delay is. So until that many number of times, until this many number is decremented to 0, 64k, this will be in the loop. Okay, the same instruction will be executed, right? So until TF0 is set. Once this FF to 00 happens, then 000 to FF, then next immediately this TF0 sets, then this instruction is means this condition is false, then this will be executed. What we need to do? Why this has to be executed? The overflow is set. Next again we have to do the same process. So in that case, as a programmer, you must clear it, because this is the overflow of the previous state. Okay, now we are just moving on to the next state. So in that case we have to clear it. So that's why we are clearing it. And then short jump to loop. Same loop continues from here. How, sir? How this continues? Say FF we placed, then it is decrementing 64k times, it becomes 0000, and after 0000, then again decrementation is done, happened, and that becomes overflow. Yes or no? And then next again after overflow, this is set. So again decrementation, still it is running, so we are clearing it, and the next we are just moving on here. Again this FF started there, its decrementation, because the still timer is on. Timer is still on. So this again becomes 0000 next time. Say no output is produced. So in that case, so what you have to do is, we can just send any output value, say to any port, say P2, right? Say an example P2, like some value, right? So like this. So any value we are sending. So generally this timer output will be produced. So if you want an analog signal, that has to be send it to, we have to send some particular number based on the requirement. We will be sending to DAC, digital to analog converter. So we will be having a waveform. So timely output. So we can adjust the time. So not only it is not mandatory that we have to keep this FF alone as a count. No. We can change based on the time duration. So say, so by checking the clock frequency, we can just find out the time duration that I explained, right? So this is how we make timer on. So whichever the facility, whichever the thing you just wanted, that can be added at any place. So here you can just produce output, and again you make another loop, right? Other portion, just reduce the count, we just change the x-axis counts. So just have a 3 or 4 sets of counts, just give a shape for your waveform, produce your output to particular port through DAC. This is how we design. So this is simplest method of running a timer 0. Hope you have understood. Thank you.